Hey y'all, so let's cover some of the different things you're going to be seeing in your homework as well as potentially on the exam. So we've got a couple questions here. One of these are all on your homework. It says, suppose you invest $140 a month for 6 years into an account earning 7% compounded monthly. After those 6 years, you leave the money there without making any additional deposits in the account for another 26 years. How much will you have in the end? So this is going to take two different formulas to solve. The first one is going to be you're putting money into an account on a regular basis per month for 6 years. That's an annuity, right? You're saving money for later and you're putting money into an account, you're depositing money. After those 6 years, and you're no longer putting money into the account, the bank will move that account to a different one and it will no longer be doing the monthly deposits. Now you're just going to let the money sit there. And that is taking money, putting it into an account and one time and you're done. And that's the compound interest formula. So we're going to need both of those to solve this problem. I'm going to do this one and I'm going to give you a chance to do the second one and then we'll do it together. Suppose you invest $140 a month for 6 years into an account earning 7% compounded monthly. This is an annuity. So we're going to find out how much money we have at the end of the annuity portion of this, which is our A. Annuity is we're going to make $140 payments or deposits. And then it's going to be 1 plus 0.07. We're putting the money in every month. And we're going to do this for 6 years. Okay. Putting this in your calculator, it would be 140, open, 1 plus 0.07. That is a 1. 1 plus 0.07 divided by 12, close, caret, open, 12 times 6, close, minus 1, close, divided by, open, 0.07 divided by 12, close, and equals. All right, so let's do that. So for my ending of the 6 years, 140, open, 1 plus 0.07 divided by 12, close, caret, open, 12 times 6, close, minus 1, close, divided by open, 0.067 divided by 12, close, and equals. So at the end of the 6 years, we have 1,240. Oh, I put a four there. Shoot. Let's see if I can do this. Sorry, y'all. Let me do it again. 140. That makes sense. Open. 1 plus 0.07 divided by 12. Close. Caret. Open. 12 times 6. Close. Minus 1. Close divided by open. 0.07 divided by 12. Close equals. That's better. We have $12,482.53. Okay. That's not what we want to know. We need to take this money and we're depositing it into our compound interest formula. And that is, oh gosh, it's been a while. A is equal to P, 1 plus R over N to the NT. So this becomes our P. This is the money that's put into an account to just let sit there. We're no longer putting more money in. So that's 12,482.53. 1 plus, the rate is still 7%. Compounding periods, we're still going to go with the 12. And then 12 times, we're letting the money stay there for 26 years. Okay, please note the difference in the years. Be careful with that. Putting this in your calculator is just clear the calculator. 12,482.53. Open 1 plus 0.07 divided by 12. Close, caret, open 12 times 26, close, and equals. So this is how much money you will have at the end. $76,634.11 in 32 years. That's the 6 plus the 26 added up. Okay. Pause the video, attempt this next one yourself. Suppose you invest $170 a month for 5 years into an account earning 6% compounded monthly. After 5 years, you leave the money without making additional deposits in the account for another 29 years. How much will you have in the end? Do your annuity, then do your compound interest. Okay, pause the video and then come back. So I'm going to start with, we're making $170 a month. Interest is 6% monthly for 5 years. Okay, putting it in your calculator. All right, so at the end of the 5 years, we will have 170 open, 1 plus 0.06 divided by 12, close, caret, open, 12 times 5, close, minus 1, close, divided by open, 0.06, divided by 12, close, and equals. So at the end of the 5 years, the annuity will stop using the annuity, and we'll have $11,860.91. This is where you round. You round right here. Okay. Do not leave the money, the amount in your calculator. You have to round this. So now we're going to take our compound interest formula, and this will become our P. 11,860.91. The rate is 6%, compounding 12, and we're going to leave it in for another 29 years. This one is what we're going to use for our final answer. So 11,860.91, parenthesis 1 plus 0.06 divided by 12, close, caret, open, 12 times 29, close, and equals. So we will have, or you will have, $67,283.33 in total in, what is it, 29, 31, 34 years. Okay. So that's going to be one on your homework, potentially your exam. This next one, this is a homework problem that I would never do to you like this. This is huge. So you want to be able to withdraw $50,000 from your account each year for 30 years after you retire. You expect to retire in 25 years. If your account earns 9% interest, how much will you need to deposit each year until retirement to achieve your retirement goals? So again, we're going to use two formulas here, but we've got to first use the payout annuity formula to find out how much money we need at the beginning of the retirement. Then we have to use the annuity formula to find out how much we need to pay in to have that money for when we retire. So it's kind of we have to do both pieces of this. Whenever I ask this question on the exam, I'm going to do it that way, even though this is what your homework's going to say. I want to give you the steps that I'm going to use for your exam. Okay. So you want to be able to withdraw $50,000 from your account each year for 30 years after you retire. Right there, I'm going to stop. I'm going to ask you, how much do you need to have saved or have at the beginning, to have at the beginning of your retirement? This is the first thing you need to ask yourself. So this is using the payout annuity formula, and we need to find P. Okay, we know we want to withdraw 50,000. Interest rate is 9%. And we're going to withdraw it per year. We're going to withdraw it for 30 years. Be careful here. We've got two different years happening. This one we want to be able to withdraw for 30 years. That's the payout annuity. So times 30. All right. Calculator. 1, 2, 3. All right, let's put this into color. 50,000, open, 1 minus, parenthesis, 1 plus 0.09 divided by 1, close, caret, open, -1 times 30, close, close again, divided by open, 0.09 divided by 1, close, and equals. So when you go to retire, you need to have this amount of money in the account so that you can take out 50,000 a year for 30 years, right? So we need, how much do you need in your account at the beginning of your retirement? You need, this is not the answer for the homework. This is just for what I would say on my exam, $513,682.70 in the beginning of your retirement. So the thing about this is, just because this is what you need at the beginning of your retirement, this is also what you need at the end of your annuity. So this is what you need at the beginning of your payout annuity, but we need to go back and see, okay, this is what we're going to need as our A for our annuity formula. And we need to know how much we need to deposit for 25 years so that we can have that. So I'm looking for my PMT. We're still earning a 9% interest. We're putting the money in yearly. So we need to know how much we're putting in per year. And it's going to be 1 times 25 years. So please make sure you check that. And then 0.09 over 1. Putting this in your calculator. We start right there. Open, 1 plus 0.09 divided by 1, close, caret, open, 1 times 25, close, minus 1, close, divided by open, 0.09, divided by 1, close, equals pause. And now we type in the 513,682.70 divided by second, answer equals. So open, 1 plus 0.09 divided by 1, close, caret, open, 1 times 25, close, minus 1, close, divided by open, 0.09 divided by 1, close, equal, pause. Now we type in the 513,682.70 divided by second, answer equal. This is how much money you have to put in every year for 25 years in order to have this amount of money at the end of your annuity and also at the beginning of your retirement, so you can take out $50,000 a year for 30 years. So this is what answers the question. How much will you need to deposit each year? You need to deposit $6,064.67 per year for 25 years. Now, we could also calculate interest because I can. Just to find out how much interest we accrue, right? Because this is money we're saving, so it's nice to know the difference. So if this is your total deposits, the interest is your total deposit. Actually, it's your total withdrawals minus your total deposits. All of it is interest. The interest for this bad boy is total withdrawals minus total deposits. So if you're withdrawing $50,000 a year for 30 years, so you're withdrawing $1,500,000. Okay. How much are we how much are we depositing? Total deposits. The deposits are $6,064.67 per year for 25 years. But that's how much we deposited. So we subtract them. So 1,500,000 minus 151,616.75. You earned, this is fantastic. So you earned 1,348,383.25. But how long did this take? 30 years plus 25 years is 55 years. That's delightful. That's interest you earned. Okay. Pause the video. Give me just a moment. I'll be right back. And then I want you to do the next one following the same method to give you a second chance. Do the same thing I just did. You want to be able to withdraw 25,000 from your account each year for 20 years after you retire. You expect to retire in 30 years. If your account earns 10% interest, how much will you need to deposit each year until retirement to achieve your retirement goals? I don't need you to calculate the interest unless you want to, but go ahead and calculate this so that you know what to do for the homework. Be right back. All right, so hopefully you paused the video and did this one yourself. I'm gonna go ahead and get started. I'm gonna start with the payout annuity. So I need to know how much money I need in the account when I go to retire so that I can take out $25,000 per year for 20 years. And I'm getting an interest rate of 10% per year, -1 times how much do you want to draw for 20 years? I need to make sure I'm doing the right years. All right, calculator. This is divided by. Okay. All right, we've got 25,000. Open 1 minus, open 1 plus. 0.1 divided by 1. Close, caret, open, -1 times 20. Close, close again, divided by open, 0.1 divided by 1, close, and equals. So we need to have $212,838.09 in the account when we go to retire so we can have $25,000 a year for 20 years. I don't need to 212, comma, 839.09 needed in the account for retirement. So that's my P. It's also my A for my annuity formula. And we're looking for how much we need to deposit in the annuity formula per year for 30 years. My nose is itching. All right. 10% per year. And it's going to be 1 times 30 years. Putting this in the calculator, we start right here. Pause. 212,839.09 divided by second. Answer equals. Goodness. All right, let's put this in the calculator. Open, open. 1 plus 0.1 divided by 1. close, caret open, 1 times 30, close, minus 1 close, divided by open, 0.1 divided by 1 close, equal pause. Now, I just type in 212,839.09 divided by second, answer equals, and this is how much money I have to deposit per year, $1,293.90 for 30 years, so that I can have $25,000 a year for 20 years after I retire. Okay. So the answer is, how much will you need to deposit? I need to deposit $1,293.90 per year for 30 years. Okay. Next thing. And now that's it. That's all you have to do for the homework. Okay. But should you want to see the interest? It's just your total. The interest is your total withdrawals minus your total deposits. Your withdrawals are the 25,000 a year for 25,000 a year for 25 years. No, 20 years. So sorry. $25,000 a year for 20 years. So we withdrew 500 grand. And the total deposited was the 1293.9 for 30 years, because it's yearly. You deposited $38,817. So you accrued, and this is 500,000 minus 38817. 461,183. So you accrued over the 50 years, $461,183. This is not part of your homework. This is just me for fun. All right. And that's it. That is the end of lecture for annuities, paid annuities, and loans. Have a great day. Let me know what questions you have.